Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, today's question is MAXADD. In this question, we're given two integers n and m and two arrays a and b. Now we define a function f of x as follows. So we start with an integer y which is equal to some integer x. Now for each I equal to 1 to up till n, in this order we update y equal to max of y plus b of I comma a of I. And our function, the final value of our function is the final value of this y once we have done this operation n number of times. Now we need to calculate the summation from I equal to 1 to m of this function f of I. Right. Now the very brute force way of doing this question would be just run a loop from 1 to m, and for each of these just put y equal to this element I, and then just do this operation for n times, and the final time complexity would be n into m. Right, that is like the brute force way to do this question, which would obviously TLE, because in the constraints we are given that t would be in between 1 and 10 h to the power 4, n would be in between 1 and 2 into 10 h to the power 5, a of I comma m would be in between 1 and 10 h to the power 9, and b of I would be in between 1 and 10 h to the power 4. And obviously the sum of n would not exceed 2 into 10 h to the power 5. Right, so we need to come up with a much better solution. So yeah, let's just look at the test inputs once and then just we'll look at the solution. So initially, let's just look at the first input first. So we have n equal to 2 and m equal to 3. Now initially we have, this is our array A and this is our array B. So let's calculate the f of 1, right? What would it be? So it would be max of 1 plus 1 comma 3, which is 3. Now the next would be max of 3 plus 2 comma 4, which is 3 plus 2 obviously. So the final value of this would be 5. Now let's calculate f of 2. So initially it would be max of 1 plus 2 comma 3, which is 3. Then it would be max of 3 plus 2 comma 4, which is 5. Okay, let's calculate f of 3. So it would be max of 3 plus 1 comma 3, which is 4. Then it would be max of 4 plus 2 comma 4, which is 6. So this is 6. Now the sum of all three of them is 5 plus 5 plus 6, which is 16. Right. You can just try out these two test cases by yourself and let us just move to the solution. So let us just look a bit more carefully at this statement first. So we're given y is equal to max of y plus b of I comma a of I, right? So can we say that this is like the previous value of y and this is our new current value of y, right? So in the previous value, like what is this? Previous value plus some non-negative number, right? This is greater than or equal to 0, right? So some previous value plus this, either this would be added or a of I would be added, and we're just putting it equal to the max of these two values, right? So because this would be greater than or equal to y, and if it is less than, like if it is smaller than a of I, then a of I would be added, right? And because we're taking max, this number, this y, would be greater than or equal to the previous value of I, right? So like the y at index I would be greater than or equal to y at index I minus 1. We can say this, right? Or like in short, we can say that y will be always like in a non-decreasing order, right? Now, this was the first observation which I wanted to make. Now, the second and the most important observation is that if at any point y becomes equal to any value, any of the values of a of I, the final value of I would be same. So what do I mean by that? So let's say for some y equal to x, y became equal to a of 3, right? Y became equal to a of 3. And we just did the operation. We just did then for this for a of 4, then a of 5, then a of 6, and the final answer, this final a of f of x that we got was equal to, let's say, some c, right? Now let's say there is some other value that is x plus anything, let's say x plus k or whatever it is, and using this value of y, our y became equal to a of 6, right? Let us assume that. Then my claim is that this f of new value, this f of x plus k, will also be equal to C, right? So our claim is that if at any point, for regardless of the starting value of y, if our y becomes equal to any of these a of i's, the final answer is going to be exactly the same. Why is it so? That is because even with this starting index, when this reaches the point 6, this y would become equal to this a of 6 only, right? Why? Because we are taking y to be max of this a of 6 comma y plus b of 6. And now if we could not get this y plus b of 6 with a bigger value, bigger starting point, then it was impossible for us to get this b plus 6 overpower this a of 6 for this value of x, right? I'll just repeat it once again. So I'm saying if we started with this value of x and we reached a of 3, then when we reach the index 6, this will become equal to a of 6. Why? Because if we could not get this b of 6 plus y with this bigger starting point, right? How could we get this b of 6 plus y with this smaller starting point? Because at every point we're just making it y plus b of I comma this a of I, right? I hope it intuitively makes very much sense. And if like the answer would be same, then we can say like this is like the main observation, right? So for any value, uh, like like this concludes us to two possibilities. Like either the number y or the starting point would become equal to any of these a of i's. Either it would become equal to these a of i's, or it would become bigger than that, right? And these lower values would be added. So it would become something like maybe some number plus something. And because these x's are consecutive, so the number would be like L comma L comma L. So for like up till some starting points, the final value of I would be equal to these. Then it would become equal to L plus 1, and then it's always going to be consecutive up till the maximum value. It will be like much more clear just in 2 minutes. So, so let's consider this case once, right? Let's consider this test case. And we'll be calculating the different values of f. So this is f of x and this is x. And we're computing these different values of x for different starting values. So when y is equal to 1, what is the final f of x? So it would be max of 25 comma 50, which is 50. 50, then it would be max of 50 plus 20 comma 75, which is 75. And then it would be max of 105 comma 100, which is 105, right? Now for 25 also, it would be same, right? So for f equal to 1, our x, like our y became equal to this 50 in the very first step. For for x equal to 25 also, the y will become equal to this in the very first step, and obviously if it became equal to this, then the answer is going to be the same. And obviously for all the values in between them also, it's going to be the same. Now for y equal to 30, it was 30 plus 24, which is 54. So it will be 54 up till this step, right? Now it would be 54 plus 20, which is 74 comma 75. So it became equal to this at this step, right? But after this, it will become equal to 105 only, right? For 31 also, it became equal to 105 only. But for 32, it will become equal to 56 comma 50, which is 56. Then it will become equal to 76 comma 75, which is 76 only. And then it will become equal to 106, right? And for all the consecutive next values, it will remain to be consecutive, right? So we can say that initially it would be L, L, L up till some indices, and then it would become L plus 1, L plus 2, dot, 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 R, right? And this initial value, this is nothing but f of 1, right? And this final value, this would be nothing but the maximum possible value, which is f of n. Now, can we calculate this summation using binary search? We can, right? We can just figure out how many L's are there, and once we have figured that out, then it's pretty easy to calculate. And we can figure out how many L's are there using binary search because it is a monotonic function. But it's not really needed. We can just simplify it a bit. So what can we do? We know that the number of occurrences of these many elements would be r minus l, right? Let's call that number equal to k. Now, how many these l's would be there? That is the total number minus these values, right? So that would be m minus k. And for all of them, this value is l. So our answer would be m minus k times l plus Now we need to calculate the sum of this, right? And this we can calculate using our simple formula. So it would be the summation from 1 to r minus the summation from 1 to L. And these two values can easily be computed using this formula in constant time. And using this, we can just easily compute our overall answer. And f of 1 and f of m can be computed in O of n time. So the overall time complexity of this solution would be big O of n. And yeah, that's pretty much the whole solution. Now let's move to the codes in C++ and Python. So yeah, this is the solution in C++. So we begin by taking in the input of n and m. We take in the input of arrays a and b. We calculate f of 1 and f of m using the normal formula. This is just our sum function, which will return us n into n plus 1 by 2. We define our k, which is r minus l. We print the answer, that is l into m minus k, as we discussed in the solution, plus the summation of r minus the summation of l. And that's pretty much the whole solution. Now let's see the solution in, okay, sorry, this is like r minus l only or something, but yeah, you get the idea, right? Now let's see this. Now let's see the solution in Python. So we run a loop for each test cases. Take in the input of n m, we take in the input of the arrays a and b. We define our l and r. So in our case, l is this and r is this. Like, sorry, we calculate the L and R. So yeah, this would be the final end and this would be the final R. And we'll calculate them using this normal formula. Then this K is nothing but R minus L. And the answer would be the difference in these prefix sums plus L into M minus K. Time complexity again is big O of N. And yeah, that's pretty much the whole solution. I hope you liked it. Thanks. Bye bye.